Hello and welcome back to Friday Minis. Last week, we looked at strings. We saw how we were essentially taking strings for granted because under the hood, they are actually arrays. Today, I'm going to extend on this idea by saying, hey, we're taking arrays for granted too. Alright, not really, but let's try and appreciate how arrays work as well. Because as it turns out, there are some things that are not really obvious. We're going to delve a little bit deep to try and understand what arrays are like in RAM, and we'll try and understand array indexing as well. Here's an interesting thing. If you've been using high-level languages like Python and JavaScript, you may not even be familiar with the idea that arrays are technically fixed length. We don't have this in Python, right? Our lists are extensible. We don't really have this in JavaScript as well. What we call arrays there are also not fixed size. But as it turns out, if we go a little bit deeper, right, if we look at the lower level, we'll realize that we must have fixed length arrays. Here's the idea. RAM is where our temporary information, namely our variables, are being stored. So you can picture RAM to be like basically a long set of pigeonholes. Each one of them is labeled by an address. When you're storing a variable, really what you're doing is you're putting information at a particular address, and your variable name is translated to an address position where you can, go there, retrieve your value, or manipulate it further. Now, an array really operates on the same principle, except we're not setting aside one pigeonhole, we're setting aside a bunch of them. Let's say when we create an array of size 10, essentially what we're doing, at the low level is we're saying, block off these 10 pigeonholes. I'm going to reserve all of this for my array. What happens then is that your computer, reserves that space for you, right? New variables are going to go, around it, but not within that space because you've already set it aside. What that means is, there's really no room for, an array that is variable length. In fact, for programming languages that allow you to have lists, which are essentially variable length arrays, under the hood, they need to, set aside a fixed amount of space, and if you exceed that space, they're going to have to go elsewhere in RAM, allocate more space for you, and then transfer the items over. So there is actually a lot going on under the hood. This expansion is something that we don't see when we're using languages like Python or JavaScript. But it is actually happening, because again, we are setting aside space, right? We've got to do that. Of course, certain data structures like linked lists work around this, but if we're staying within the range of, just flat arrays, areas in RAM that we've set aside, this extension is something we cannot avoid. Here's one more thing that may be of interest that we should discuss before we move on, and that is the whole idea of indexing an array. Have you ever wondered why indices start at 0? As it turns out, there is a good reason for it, right? It's not just because, we're programmers, we like to do things that way. There is a good reason. Remember, an array is space we've set aside. The question is, how do we represent this array? As it turns out, the only thing we really need to remember is the position of the very beginning. It's the address of the first element within the array. The reason why this is so is because, in order to access the subsequent elements, we simply start at the first position and count our way down. So then, how does indexing work? Here's the deal. The indexing actually specifies an offset. It tells you how far ahead from that recorded address to actually look. If I'm looking at the first item, I don't have to have any offset, and that's why the value is 0. Simply go to the recorded address, that is your first item. Of course, your computer doesn't actually, start at the beginning and count one by one. Since memory addresses are just numbers, it simply performs an addition. That is why finding things within an array is very fast. All I need is a starting point and an offset, how far I need to jump forwards. I'll do the calculation, that gives me the exact memory address to jump forward to, and that's the item I want. So there you have it. That's arrays in a nutshell, and hopefully that gives you some insight as to why arrays are so powerful and how much of it has been abstracted away from us, how much of it we don't have to care about. That's all there is for this episode of Friday Minis. Thank you very much for watching, and until next time, You're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.